look at AC circuit. Look at AC circuit containing inductor only. Please draw out the diagram for this. What do you have? Containing inductor only. Which one? Inductor only. Should be having this. For inductor, we should be having this into, I said this is section for inductance. Of course, from here, what do you have now? You have current going upwards. This is your I. And of course, you have VF here. I said VF means what there? Voltage frequency supply. Called VF. Voltage frequency supply. This becomes inductor. That's F. Inductor F. Inductor is used to measure inductance per se. What's the SI for inductance? Huh? Henry. Okay. Think of this. The voltage supply for this circuit, the voltage supply is given by V is equal to I, what there? X N. For resistor, V equal to IR. For capacitor, V equal to what there? IXC. For inductor, V equal to what there? IXL. Now, see the difference. See the difference, please. Where XL is called what there? The reactance of the inductor circuit, reactance, and XL is equal to 2 pi L. See the difference. For XC, I'm taking inverse 1 over 2 pi FC. For XL, there is no inverse, it's just straight 2 pi FL straight. That's the concept. Right? It's called the reactance of the inductor circuit. What's a reactance? What's reactance? Note. Okay, before that, let's liken this. Look at this. Let's liken this to RMS and peak. What would you have? For RMS, what do you get now? V RMS is equal to what there? I RMS times what there? XL. Liking this to peak value, what do you have there? V naught is equal to what there? I naught times what there? XL. Very simple concept. Very simple concept. So all of these are just to make you see what's changing. It's just from R to XC, from XC to what there? XC. That's all. No big deal. That's all. No big deal. All right. What's next there? Good. I was asking, how do we define a reactance? How do you define a reactance? What's a reactance? Let me explain the concept before I give the definition. Here's the concept. When we did resistor, we said V is equal to I for resistor. For capacitor, we said V is equal to IXC. For inductor, we said V is equal to IXL. Now here's the concept when it comes to AC. In every circuit, one of the key elements in every circuit is what? A resistor. That's like a key concept in every circuit. Every circuit should have a resistor. Why? Resistor or resistance is what? The opposition to what? The flow of current in what? A circuit. That's a resistance. The opposition to the flow of current in an electrical circuit. So when you have a circuit without a resistor, what does it mean? It means that that circuit is prone to damage easily. So here's the concept. If I pass a very high current through a circuit, If there's no resistor, what happens to the circuit there? It could burn things there, or it could damage what? Things in what? In the circuit. Just like when you're having a high current. If you have a high current and then there is no, what do you call it, stabilizer, it can blow up the television. So you can liken that concept to what? A resistor. There must be something that has to do with wage the what? Value of what? The current. That's the concept. And that's what the resistor. Now, if I'm looking at an AC with a resistor concept, it's called a resistor. What is an AC with a capacitor? It's called a reactance. A reactance and resistor are the same thing. What's the difference? Of course, even if you check their SI unit, this man here is in ohms, this one here is in ohms, this one here is in ohms. The difference is just what there, a change in name and what again? A change in formula. For this one, it's now equal to inverse 2 pi fc. For this one here, it's not inverse, it's just straight 2 pi fl. So what would you define a reactance? By definition, a reactance is simply the resistance offered by an AC circuit when it's containing what? Either a capacitor or what there, an inductor. That's the definition. Definition, let's take down. A reactance is the resistance offered by an AC circuit when it contains a capacitor or an inductor. When it contains a capacitor or an inductor or both. That's all both. Alright, think that way. Let's do some fast question. We'll stop at this point. There's reactances, there's impedance. It's what we call impedance, but no problem. Let's see about this part. Think that please. Sample problem, question 1. Sample problem, question 1. Sample problems, question 1. In an AC circuit, the ratio of the RMS value in an AC circuit, the ratio of the RMS value to the peak value of the current, the ratio of the RMS value to the peak value of current is given by dash. The ratio of the RMS value to the peak value of current is given by dash. A, B, C, or D. Now look at this. Look up. Solution. Let's get it done. Let's get it done. Look at it. Now, question. What's the relationship between RMS and peak? What's the relationship? Of course, we said RMS is equal to what there? I for what there? 2. Now, ratio of RMS to peak. What does it mean? When we say ratio, what do you mean? Division. Ratio is division. So ratio of IRMS to I naught. What does it mean? It means look for a way to express this in terms of IRMS all over I naught. So how do I express this? How do I convert this to something that looks like IRMS all over I naught? The ratio of the RMS value of current to the peak current is equal to that. So how do I express this in this form? What do I do? So I do what there? You say divide. So to multiply this like this, I have root 2 IRMS is equal to what there? I naught. Divide here by IRMS. Divided by IRMS. This cancels this.
The reactance first after they take the inverse of both sides.
Am I correct? Is it correct? Is it correct?
Yes, they take inverse.
This one of you always do loss when you do maths. As if you never did maths, like you never passed secondary school. Right? How would you solve this? Yeah?
Take the inverse now.
Okay. So I'm having that root 2 is equal to I naught all over I RMS. Do what? Then take inverse. Take inverse. If I take inverse, what do you have now?
1 over root 2.
So 1 over what? Root 2 equal to what there? I RMS. All over what there? I. So what's the answer there? A. But why is it that you like suffering yourself? Why do you like to suffer yourself? See simple concept. I/MS is equal to I naught over 2. How do you solve this? Very simple. Carry this man here, becomes all over I naught. Here is left with 1. So simple. So simple. What is it? What are you dividing? Don't say go and do math. Say no, don't do math. Don't do math. Please, this is your answer. Okay. If you don't like this, no problem. But listen, I've said before, jam stuff are easy. It's just like you have the technicality, you do it very fast. That's the thing there. So in this case now, it's as simple as break this man. Of course, you can say 1 here. You can say swap these 2, swap them. 1 goes here, 2 comes here. That's simple. You can run this stress. Right? Time is reading. You don't have all this time. Your answer there is 8. Question 2. The DC generator, question 2. The DC generator has essentially, question 2. The DC generator has essentially the same components as the AC generator, except the presence of dash. A. Slip ring. B. Carbon brushes. C. Split ring. D. Armature. What's the answer there? Huh? Split string. A. Slip ring. B. Carbon brushes. C. Split rings. D. Armature. What's your answer? Huh? Is it slip or split? Slip. Listen. A is slip. C is split. A or C? Listen to your question. The DC generator has essentially the same components as the AC generator, except the presence of dash. What does AC have that DC does not have? Is it a slip ring or a split ring? I said it before now. Huh? It's split ring. What's the function of slip? You convert what there? And what? AC down the what there? Question 3. Question 3, please. At what frequency will a 12.0 millihenry at what frequency will a 12.0 millihenry inductor at what frequency will a 12.0 millihenry inductor have a reactance of 880 ohms. Have a reactance of 880 ohms. See your option. Alright. So let's solve this, please. Let's solve this, please. Solution. What do I have there? What are you giving parameters? What do I have there? You have inductance. Huh? You have 12.0 millihenry. What's millihenry? What does it tell you? Inductance. Inductance is measured in what? Sorry, what's the symbol for inductance? Huh? Current is I. Voltage is V. Whatever. Resistance is R. For inductance, what's the symbol? Huh? You have L, inductance, being equals, what do you get there? 12.0 millihenry. Now, see where I put my millihenry, small n, capital V. Please, convert this millihenry to henry. What's the value of milli? Tell me about what there? Minus 3. Gives you 12 times 10 to the power minus 3 henry. That's it. So milli to the power minus 3. Next, they say, have a reactance of what? 880. What's the symbol there? Which symbol is that? It says X. There are two X's there. Is it the XC or the XL? XL. What's the XL? It's an inductance circuit. I'm having XL is equal to 880. Obviously, it's in ohms. It's in ohms. I explained this earlier. It's in ohms. I'm asked to find frequency F is equal to unknown. Which formula relates this? Recall, I will say that word there. XL is equal to what there? 2 pi FL. Alright, we have to find F. To get F now, I'll divide there by 2 pi F. Divide there by 2 pi F. This times this, L to L. Means that F is equal to XL, all the word there. 2 pi F in truth value. So I have that F is equal to what's XL? Becomes 880 all over 2 into pi into L 12 times 10 to the power minus 3. Please give me value. You have what there? 11671.36 36 what? Times 10? Okay. So you're having this word there in hertz, right? In hertz, obviously. So which of them here is your answer? If I do from here now, if I do approximation, it becomes to this now. Of course, you observe most of the figures here are given in 3 digits. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the concept will now be to approximate to 1, 2, 3. I will approximate this to this. 7 is a plus 1. So having 1, 1, 6 plus 1, 7. Here is 0, 0. 0.00 hertz. If I should write this now in standard form, now gives you this is 1.17. If I put a point here, I have to move 1, 2, 3, 4. I'm moving 4 to my right. It becomes times 10 power forward there. Hertz. Hence, your answer is A. What I'm seeing here is a 1 point. 1 point. So I'll come here, 1 from here, I'll put a point here, 1 point from here to my initial point becomes 1, 2, 3, 4. That's it. I'll do this hertz. That's the concept. Take down please. Sample problem 3. Take down. The RMS value of a supply voltage. the RMS value of a supply voltage is quoted at 220 volts. Is quoted at, please, 200, please, sorry. Is quoted at 200 volts, full stop. What is the approximate peak value of the voltage? What is the approximate peak value of the voltage? What is the approximate peak value of the voltage? Alright, so there are your options. Please, in this question, please, what am I given and what am I required? What am I given? Of what? Huh? Of voltage. So what's your representation for RMS of voltage? How do you write it? VRMS. I'm giving VRMS. How many there? 200 volts. I'm asked to find the peak voltage. This is unknown. Alright. So what becomes my answer? How do I solve this? What's the formula? We said VRMS is equal to what there? V naught over what there? 2. We'll find V naught. This is all over 1. This times this. V naught times 1 is V naught. Is equal to this times this. Root 2 times 1 there. VRMS. In peak value, this is equal to root 2 times what's VRMS? 200. Please give me value. 28.84 volts. The question says to find what there? The what? Approximate value. Find approximate value, please. Approximate this. What do you get here? 283 volts. What's the option there? Option C. Option C. Alright. Another question. One last question. One last one. So with this now we finish all the questions for the last 10 years. Whatever you see, you like it to this. Example. An alternating current with a frequency of 100 Hz. An alternating current with a frequency of 100 Hz has a period of dash. 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 What's your answer? What's your answer? Huh? What's the relationship between period and frequency? What's the relationship? Solution. I'm given, I'll give frequency, right? Frequency small f. How many? 100 Hz. I'm about to find T, period. What's the relationship? T is equal to 1 over f. That's 1 over. What's f there? 100. That gives you what there? Alright, so I'm having this as my answer. So ladies and gents, we finish another topic again. Right? So next class.